Thank you for joining me today here in Perth. My name is Jamieson. I'm a geological consultant here with Datamine software. And today we'll be looking at the Drillhole Importer, a relatively new feature for Studio RM. It was introduced in version 2. We're currently at version 2.1, and it's for importing your raw data and desurveying them into drill holes. Previously, the process was a little bit different, but we'll go through, what the Drillhole Importer is, and, why hopefully you'll find it better than what we had in place before. Okay. Okay, and so let's launch into the demo. Okay, so we're in Studio RM 2.1 here. I'll be looking at the Drillhole Importer. Of course, all of our drill hole tools lie in this sample analysis ribbon. And so for a little bit of background, prior to version 2 of Studio RM, the principal way of importing your drill holes was to take your CSV files from your database, convert them into Datamine files, and then you would go through the Holes 3D process. Doing that manually required manual conversion of those files to Datamine format and then running the process. And of course, that could all be recorded to a macro as well. And so that was for static drill holes. And then we had dynamic drill holes, which was a way that you could create an ODBC link to a database and quickly import and refresh your holes through the dynamic drill hole wizard. Dynamic drill holes, though, only exist in memory in the 3D window. They don't constitute a physical file, and so they couldn't be used for additional transformations or estimation. For that, you do need a static Datamine drill hole file. And so the Drillhole Importer, this button up here, basically supersedes Holes 3D and is the way of easily importing, validating, and desurveying data from a variety of formats into Studio RM. So your files don't need to be in Datamine format to begin with. They can be in a number of formats. They could be text files, tab delimited text files, comma delimited CSV files. And we can even create an ODBC link to a database or link directly to databases like Acquire or Fusion. And so we'll look at a couple of different ways of doing things today. We'll see how we can easily drag in CSV files, and we'll also make an ODBC link to a little sort of dummy training database that I've got as well. And so as we go through, we'll look at all the different features and options in the Drillhole Importer. Please, if you do have any questions along the way, leave them in the chats and we'll attend to them afterwards. We will have some open question time after as well. Okay, and so through here, let's say I want to import some CSV files. You can easily do that from File Explorer. Sorry, just let me find my CSV files. Okay, so I've got a number of CSV files here. All I'm going to do is make a selection of the files I want. So I've got assays, collars, surveys, lithology, and drag them into this window on the left. And so it's recognized what category each of these files belong to. Obviously, to create our drill holes, we've got some collars. At the very least, we need collars and assays. Hopefully, you've got some surveys as well, and your lith logging in a table too. I'll just expand that window over a little bit. Okay, and so let's just take a look at what's going on in this window here. So we've got each of our file types. If for whatever reason it has misclassified one of your files, you can tap on one of those files and move it to a different heading. But it has automatically recognized each of my file types there. In the source column, it's simply telling you where that file has come from in Windows Explorer. It's giving you the file type, number of records in that file, and this mapped column is simply indicating that all of the fields in your input files are being correctly mapped to what the software needs to know to desurvey your drill holes. So ideally, there should be a green tick for each of those rows in the mapped column. If there isn't, then we'll see, how we can map them. And date last imported is simply telling you, when those files were actually last imported into the Drillhole Importer. So, you might have done it yesterday, for example. And so if you tap on one of the headings, here we've got collars. And on the right here are my field definitions. I can see each of the columns in my collars file. And so firstly, if you've got a big file here with a whole lot of columns and you don't necessarily need all of those, you do have the option to switch them on and off. Column name is the name of that field in the input file. Mapping type is important. So obviously the software needs to know which column contains the whole ID. And in your input files, they don't need to be formatted as BHID, X collar, Y collar, Z collar. They could be, whatever those fields are named in your database, be it whole ID, eastings, northings, elevation. You can be flexible with those field names, as long as they're mapped correctly. And so BHID is mapped as such. Output name will be BHID, and you can see that's so for X collar, Y collar, Z collar. And so everything's mapped correctly, so the process knows where everything is. We've got a formula column here. And so with this, you can apply transformations to numeric data. For example, if you wanted to change the elevation of all of your data as you import it, you could apply a Z transformation such as Z collar plus 1000 or something like that. And so when you import them, it'll simply transform all of the elevation values. Okay, and then we've got source table. So it's just telling you which of your input tables that information is coming from, and alpha width. So if you've got alphanumeric fields, how wide are they? And that can be useful to know. Often in your list table, for example, you might have a columns field, which is quite long. The limit is 256 characters, but it's just telling you that, so you know that information. Okay, and so that's with some CSV files. And so what I'll do is I'll just delete all of these, and I'll go ahead and show you how you can connect to a database through here. So to begin with, I'm just going to run ODBC data sources to create a database connection. This isn't something you may need to do. This may already be done for you, but I'll do it as part of the demonstration. So I'm going to add a database connection, and keep in mind it must be 64-bit, pick the Excel driver, because I'm going to link to an Excel spreadsheet database, and finish. Give that data source a name, and you can give it a description, just test. Select the workbook that I want to link to. And so I'm just browsing through my file explorer here. All right, and here's the spreadsheet that I want to link to. So I'll select that and go OK, and OK. And here is my new ODBC link for that spreadsheet database. So now I'll go OK. And if we take a look at that file, we'll just quickly see what's in there. So it's just a basic database with a separate spreadsheet for my collars, surveys, lithology, assays, and domains. And so now to link to that database, I can go to this little icon up here, add connection, and you'll see you've got options to link to Acquire, to Fusion, and ODBC. So I'll pick ODBC, and I'll pick the link that I just created, DH Importer. OK. I'll give it a name. OK. And so now to import the tables from that database, I'm going to go to this little drop down, and you'll see there's the database link I've just created, DH Importer. I'll pick that and go Add Table. And now I'm going to pick the tables that I actually want to bring in from that database. So obviously assays, collars, lithology, surveys, zones, and OK. And so again, it's categorized each of those different tables correctly. It's good to see that they're all mapped properly. And you can see there's the connection string for that database link. And so there shouldn't be anything to change here. Everything is mapped correctly. And we'll look at some of the options for saving and sharing database connections further towards the end as well. So now we've linked to our database, the next step is to validate our data. And so I'll tap the validate button here, and it's going to go through and it will pick up on a number of issues, errors, or just things to be aware of with your data. So, these might be any inconsistencies or errors in your database. Ideally, it will be perfect, but unfortunately, that's not always the case. And so, I can see each of my tables as a tab here. In my collars, I've got a couple of things going on. Now, these alerts are color-coded. Orange means it is an alert. It may not be critical or fatal, but it's something you should just be aware of. And so in this case, it's telling us, we've got a couple of collar records missing for some of our holes. And it's telling you which holes they are. And so, this is a prompt to go to your database and see why those holes are missing collars. Okay. And so now let's look at assays. You'll see we've got 46 different issues or alerts that it's generated here. So remember, orange is an alert, red is an error, which could be critical and could prevent desurveying of the drill holes when we come to that point. And so in this case, this column here with the hashtag is the record number the error is at in the input file. It's telling you, the hole the error is in. And in this case, we've got downhole 2 from beyond end of hole depth. So if I tap on that error, I can see some additional information in this window on the right. And what it's telling me is the length recorded in the collar file for that drill hole is misaligned from the actual logged depth in the assay file. And so, we have different options to fix this error in here. You can manually make adjustments to that record in this window. Alternatively, many errors will have a quick fix option. So you can see there's this quick fix button down here. And the quick fix will implement, what the software thinks is the best solution. That may not always be what you want to do, and so you may want to edit this manually. But in this case, you can see the quick fix will reset the end of hole depth in the collars file to the final logged 2 value in the assays file. So you can see the collar length is 279. The final assay depth is 402. So I'll go quick fix, and you'll see it's reset the collar length to 402 meters. And so you can go through one by one, making whatever fix you deem most appropriate. Alternatively, you can automatically apply a quick fix to all errors with this icon in the top left. So I'll say automatically apply quick fix, and I'll tap refresh to implement that fix. And you'll see in the action column, the quick fix has been implemented for all of these errors. And you'll see here, we've got an additional alert, sample interval gap. Now that can be perfectly valid. It's not necessarily a problem. You may not be sampling the entire drill hole. It's just telling you you've got gaps in your sampling or your logging. And if we go to the rules button up here, we've got a couple of additional options. We can say, I'm not too fussed about sample interval gaps. I don't need to know about that. Don't worry about it. Likewise for duplicate collar locations. If you're drilling multiple holes from a single collar, that may be perfectly valid. You can set a tolerance for what is considered a duplicate collar, or you can say, I don't need to know about that at all. Okay. And we'll look at these survey options in a moment as well. But if I go OK now, and I'll say yes, refresh, you'll see it's no longer warning me about all of those sample interval gaps. All right. Now, if I go to the intervals tab, so these are my zone values for my drill holes. Again, it's simply telling me that the collar length and the end of hole length logged are misaligned. And so it's applied the same quick fix here as we did for our assays. And now if we go to the lithology tab, again, we've got a few different errors. Many of them are the same as we've already seen. We've got a new one here, overlapping samples. And so it's just telling us that, the to depth for one sample overlaps with the from of the next. Quick fix won't actually do anything in this case. And so, you can see what's going on here from 0 to 3, from 2.5 to 226. And so you'd probably go back to your database, maybe go back and look at your core photos and see what the truth is. But for our purposes here, I'll just arbitrarily change that. And you'll see action, manual edit. And so now that I've fixed everything, I'll go commit to commit all of those changes. And now you'll see there are no more errors being reported in here. For the surveys, now I've just eliminated the survey errors we had. But if we look at the rules here, you can set, so the surveys will report on any extreme curvature changes in your drill holes. Obviously, if your drill hole is, the bearing is changing by 90 degrees in 10 meters, that's a red flag. And so it will report that. And you can set what you consider to be a large curvature departure for your drill holes. So for example, the default here is 10 degrees over 10 meters, but that is changeable. Okay. From this button, export, you do have the option to export a CSV file with a summary of all the errors you've encountered. The idea being they're recorded. You could share that CSV file with your database administrator and say, you know, we've got a few things that need to be tidied up in our database here. So here's that CSV file. It's telling us, you know, what table the error was encountered in, what type of error is it? Is it just a warning? Is it an actual error? What was the hole? What was the description? What was the action you took, if any? And what was the depth, the from and to of that error? Or for surveys, the at depth. Okay. All right. So now that I've validated my data, the next step is to DesSurvey. And so in here, under alpha field widths here, it's reporting the longest width of characters in that field. And you do have the option to change it. For example, if you've got a comments field with 500 characters or something like that, and you want to limit the width, then you could check on that field, pick the new field width you want to implement. Let's say, actually, I want to restrict length to 4 characters. This is just an example. And so that should reset the width of that file in the output. Perhaps that's not more. There we go. Sorry, I tried to make it shorter. You can extend the width of that field to accommodate the characters, but we won't shorten it. Okay. And so the next step, we can set some options or parameters. For those of you who have used the Holes 3D process, many of these parameters will be familiar. And so we've got the option to add samples for each survey record. What that means is, say you've got a continuous downhole survey and you've got multiple survey records within a single sample. Each sample is essentially a straight line in space with the sample coordinates at the center point. And so you can't have more than one survey record per sample, because then it wouldn't just be a straight line. And so this option here, add samples for each survey record, will basically split that sample into halves, compositing it, until there is only a single survey record per sample. So it will create additional samples in the output, which is something to be mindful of. Alternatively, if you switch that off, then only a single survey record will be used from each sample. But that does mean that not all of your surveys are being taken into consideration. So, If you do turn that on, you know, and it splits your samples down, you do then have the option to composite your drill holes by sample ID to then restore so that you only have a single record per sample. Each sample isn't broken down into multiple records. We've got the option to include dip and dip direction from your collar table, if that information is there. The option to include sample end coordinates. So in a Datamine drill hole file, X, Y, and Z are the center points of that sample. Each sample is essentially a point in space. But you do have the option to write in additional fields with the coordinates of the start and the end of each sample. Positive dip down is one to be mindful of. So, you know, depending on your survey convention, if, you know, you've got positive dips going downwards, you would enable this. If you've got negative dips for downwards, which I think would probably be more common, then you would switch this off. I'll turn it on because that's just the nature of my my data set here. And if you do have absent intervals in your assays or your lithologies, you can choose to fill those absent intervals. They'll simply be assigned absent values for grade or for lith, but there'll still be a drill hole trace through those absent intervals. And so I'll go, okay, I've set my parameters. Next step is to create a name for your drill holes. I'll just keep the default name here. And we've got a couple of different options when it comes to generating our drill holes now. You know, if I enter a new name here, there's no existing drill hole file by that name. It'll just create a new drill hole file with the name that I've entered there. If I want to overwrite or append to an existing drill hole file, you could pick that drill hole file through here. It must be loaded into memory though. And you then have the option to overwrite or append to that existing drill hole file. If you go retain existing drill holes, it will simply append any new data that's being imported into that file. If you do not use retain existing drill holes, it will overwrite that existing drill hole object. I'm just going to create a new drill hole file now. And so I'll go generate drill holes. It'll take a few moments to think about that. We can see here, we've got a little summary of the holes we're importing. You know, how many holes are you bringing in? What's the total length? You know, what's the average grade, length weighted average grade? You know, how many samples you've got for that grade. So you've got a little summary, you've got total. And if you were updating an existing drill hole object, it would give you the total, so including existing data as well, and then update. So it would tell you, you know, what's the new data that you're adding here. Okay. And so I can now close out of there, and you'll see it's created a new drill hole object for me. It only exists in memory at the moment. It hasn't created a physical drill hole file. You'll see in Sheets, I've got my new drill holes. And in loaded data, it's also loaded into memory the tables that I've imported. And so if I then want to, you know, save that to an actual file, it's as easy as right-clicking, data, save as, Datamine file, okay, and save. And so now if I go to my project files, drill holes, here's my new drill hole file, and you can see here's all the data in that table. And so that's the basic workflow from start to finish with the drill hole importer. If I open it up again, then I just want to take you through a few of the additional options up here. So when we start in here, we've got a scenario. And so we can have multiple scenarios. Perhaps if you're drawing on multiple data sources, you've got some, you've got a database you want to import to. Maybe you've got a separate access database you want to bring drill holes in for. And so you can establish multiple different scenarios for each of your data imports. So, I could have my ODBC link here, and I could make another scenario, and I could bring in data from some CSV files in here, for example. Okay. And so we've got a few additional options up here. Create new scenario, copy scenario, delete. Importantly, we've got export. So the scenario is saving all of the settings that we've put in through here. All of our validations, all of our desurveying options. And so you can save this scenario. It's being saved as this DMAHSV file type. I'll just call it webinar. And so now that scenario exists as a file that you can share with somebody else. Here we go. And so they can replicate that drill hole import case on their machine. In the case that you're importing CSVs, text tables, that scenario will actually save the data that you're importing as well. So if you share that scenario with somebody, they've then got the data from those files that they can import. If you've got a database connection that you've set up and you want to share it with somebody else, then we can go save connection. And I'll call this one webinar as well. And this is being saved as this .cfg file type. So if I go save, then in my project directory, I've got that database connection as well. And so now, for example, if I delete that database connection and I make a completely new scenario, let's say I'm on a different machine now, I can load that database connection that I made before. And you'll see from the drop down, I've now got that link. Go add table, pick the tables you want to import. Okay. And you'll see I've re-established that database link. I've also got the option to import the scenario that I just saved. Okay. And now if I go to the validate ribbon, you'll see it has saved all of the fixes we did before. And so if you've gone through and manually adjusted a whole lot of stuff through here, you don't have to do that again for the existing data. You may have some validation issues in the new data you're importing, but you don't have to repeat everything that you've already done. Okay. And so that's really the workflow for the drill hole importer from start to finish. I suppose some of the key things to remember are that you can bring in data from a number of different sources and formats. So whether they be text files, CSV files, we can link directly to a database. We can validate our data through here. So be conscious of, what errors are actually in our data, what we're doing to fix them. Ideally, those issues should be fixed at the source, which is the database. So we can export a summary of the issues we come across so that they can be addressed in the database. We can desurvey our drill holes. We can append to an existing drill hole object. And we can save everything we do through there to a scenario, which we can then share with other people. We can save our database connection as a file, which can then be shared with other people as well. And so in doing all of that, it becomes really easy to quickly refresh your Datamine drill holes whenever you need to do that, whether it's on a daily, weekly basis, however frequently you're doing that. And so that really concludes everything I've got to show you as part of the demonstration.